All right, here we go. I'm recording. I think I'm up to take four at this point. I'm going to get it this time, though. Let's talk about Greenfoot. Fantastic system for creating event-driven programs, things like puzzles, games, simple animations, simple story narrative type things that have user input for introductory programmers. So you can do this in your very first Java course, which is what we're going to do. Greenfoot is from the makers of BlueJ, which is a really cool introductory editor. We don't use it in our course for various reasons. We switched to VS Code right away, but the Greenfoot and BlueJ are both excellent. Just a quick note about Greenfoot, the API is pretty good. Um, here's the link to it. So if you pop it open, here it is. It's just one package, the Greenfoot package, and there's only what, one, two, three, four, five, six, seven, eight, nine classes. And two of them are just like colors and fonts for managing text and things like that. Not particularly complicated, not particularly overwhelming for novices. This is really tight and compact, and it doesn't have a lot of like fat on the bone. It's really just the stuff that you need. So that's a great thing about it. So the three example programs we're going to look at, we've got Hedgehog, we've got Shooting Game, we've got Cards. They're just three different interesting sort of interactive game type things we can look at. We're going to start with Hedgehog. This is a sample program I got from greenfoot.org, but I can't find the original link. Hedgehog is one of the built-in icons that you can make an actor, which is sort of like I don't know, an entity that can do stuff in your Greenfoot programs. Uh, the hedgehog is a default image. So there's a lot of things with hedgehog in them. So when I go and search for hedgehog, I just find like a whole ton of stuff about hedgehogs. And and I think there's a forward button in here. There's just a lot of stuff. So I can't find the original example. So I apologize to the original creator of this program, which is a student somewhere who uploaded this to greenfoot.org. I apologize that I can't credit you. It's a pretty simple student project. It does have room for improvement, but it demonstrates really well a bunch of really core features of Greenfoot and of event-driven programming with very little code. So it's a pretty compact example. So to get the example, I have it here in Google Drive. This is for the people I'm working with on this particular grant, but you could get this from Google Classroom, wherever you have your link, you would, bring this to download. Or if it's open like this, you could do the download link here, or do the thing where you tell it to open. Well, this is open in another window, and then you get the download link. Just whatever you need to do to get the download link, and then download it. Once you have it, I have these here in this Greenfoot folder. You can go ahead and unzip it on Mac. You just double click it. Windows, you have to right click and say extract all or something like that. And you get this Hedgehog folder. Now, in the folder, it's got a whole bunch of stuff in here, but the main thing that we care about to start it is the project.greenfoot folder. So you notice Greenfoot is not open right now, but if I double click this, Greenfoot's going to open up automatically. I'm on version 3.8.2. I don't know if that's a good version or whatever, but that's what I have. So we've got our example. You can see we have world and my world, and we have actor and a bunch of actors. So actors are like entities that do things, and world, broadly speaking, is the world that contains them. So the sort of screen and kind of all the stuff that's in it. These are all using subclassing, base class, subclass. So my world is a subcategory of world. Now, in practice, there's only one instance of world. It's this one, but you could theoretically have more. So it's not a great example. It's not like person and student, where person is a category of all the people, and student is a subcategory with many different examples in it. I'm a student of life, and my daughter's going to be in kindergarten, so she's a student, and I don't know, all the students in my class are students. So there's many examples of students, and then all the students are also people. This one, there's like world is this category with a bunch of different worlds that could be created, and my world is a specific one. But in practice, my world's a category and it's just this one world. I'm probably not going to create a lot of instances of it. Actor's a little bit different. Hedgehog, there's only one, but pizza, you can see there's four, and balloon, there's two. And we could imagine a world where we have to create more pizzas, or maybe there's two hedgehogs and you drive one with ASDF and the other one with the arrow keys or something like that. Maybe it's a multiplayer hedgehog game. There's a lot of different ways you could sort of imagine this where you might need to have multiple instances of hedgehog, right? So hedgehog's a category. Currently, there's only one of them. Balloon's a category, but there's two. And pizza's a category, and there's four instances. So just some quick notes of like how to read this. Now, do you need to know any of that in great detail to use Greenfoot? No, but I wanted to provide all the information. So if we go back here, um, we want to start with super and add object in my world. So to get these, you just double click it and it'll pop open with the built-in editor. You can see I'm importing greenfoot.star. That gets all, nine or whatever of those classes there are and makes them available. We're going to use not all of them in this project, but we'll use a lot of them. So you can see we have my world, which extends world. So here we can see the extension. My world is a category that's a subcategory of world. Again, you don't need to know that. And to be perfectly honest, this is not a great example of like base class, subclass, because they're really just extending world so they can inherit all of world's methods. It's really just a mechanical detail. To some extent, it's the same with actor. But what are you going to do? These are not as clean examples of like person is a category and all persons have name and student is a subcategory of person and students have a name and a student ID number and undergraduate is another subcategory of student who has a name and an ID number, or maybe first year student, and they have a first year dorm, and a second year student has a second year dorm and a something something. I don't know, whatever it is. You know, um, this is not a great example of that. So it is what it is. They're doing it more for the mechanical details. All of these things here, this is just stuff from the game. There's a balloon and a hedgehog and a pizza. And we actually don't create an example of a phone. I just have phone in here just for no reason. We end up not using it. These are all instance variables. And you can see we're initializing them. We're calling the constructor here. And we know they're instance variables because they're inside the class, but they're outside all the methods. So that definitely means that they're instance variables. Now we do have a constructor for my world. And if we look at this, it's calling super. And as we all know, super calls the superclass constructor. We may not know that. I'm just kind of being a wise guy here. I'll explain what this does. So you inherit all of the stuff that world has. You inherit all of its methods and you inherit all of its data. In practice, what this means is if we go back to the API, right, these are all the classes and we look at world. So this is an abstract class, which means that you have to create an instance of it. Or sorry, you have to create a subclass of it in order to actually use it. It's got the constructors, world width, world height, cell size, and then bounded. I don't really know what bounded means. I guess maybe that means that you can't go off the edge of the screen or something. I'm not really sure. But in practice, look at all these methods: act, add object, get background, get cell size, whatever. All these methods are in world, which means that when you have my world extend world, you inherit all these methods, which means you can call any of these methods. You don't have to write how to show this text at this XY location. That's already written for you. You can just go ahead and call that method because you've inherited it from world. You can, well, probably don't need to call repaint, but you can get the width of the world. You can get the number of objects that are in the world. So like how many pizzas and hedgehogs are there and so on and so forth. That's actually really convenient. Now, one of the tricks is one of the methods you inherit is whatever constructors world has, but just a quirk of Java, you don't necessarily know what you know. There's constructors, but you don't know what their names are because constructors always have to be named after the class. So they've decided super is going to be their word to call a constructor you inherited. Why is this? I don't know. In different languages, they use different things. In C sharp, they actually don't use any syntax. They just use like a colon and you put the parameters after it or something. I don't remember what C++ does, but it's probably wildly complicated and I need to cast everything to void star. That's a C and C++ joke. Don't laugh. That's not a good one. I don't remember what they call it in other languages. I'm trying to think. Does Python have something to refer to the super? Maybe it's just super. I don't know. Anyway, it's super. And so we're calling this is the width, this is the height, this is the cell size. So basically this means 600 by 400 cells with the cell size of 1 by 1 pixels. So really what that means is it's 600 by 400 pixels. So that's if we go back to here, this is 600 pixels wide and 400 pixels tall. Why? Because that's what I told it to be. And it's of size 1 pixel. You know, if I make this a 2 and run it again, I'm hitting, by the way, I'm hitting Command K on Mac. Control K because I don't want to have to go up here and click the compile button. So to make changes, I'm hitting Command K, or in Windows, it would be Control K. That's just the shortcut to compile. You can see here, the screen is now bigger, but the images kind of stay the same size. So now each cell in here is like 2 pixels by 2 pixels. So you can do stuff like that. Um, it's sort of annoying that when you do that, it doesn't rescale these. Also, now this is too big, so I need to make this smaller now. Yeah, there we go. Okay, cool. So, other things you'll notice is we are calling this add object. So, super calls, by the way, I should say this, have to be the first line of the method. I mean, the first code line of the method. You can have comments and stuff like that. The compiler just ignores this, but this has to be the first line of executable code inside the constructor is the super call. That's just has to do with it's not important why. I'm pretty sure it has to do with multi-threaded issues and synchronization and something, something, something. Don't worry about why. Just remember that's how it has to be. Um, these add object calls, this is a method that we inherited. How do we know? Well, we can just go look at it and look for add object. There it is. So I can add object, which is an actor. All these things are actors. We'll talk about actors in a second. And an X and a Y location as to where they're going to go. So I'm adding HH, which is hedgehog, to 300, 100. And I'm adding BA, which is balloon, to 200, 200. Let's talk a little bit about coordinates. Just because the way computing works, this is 0, 0, and this is 600, 400, or 599, 399, I guess, technically. Um, why is 0, 0 the top left instead of the bottom left? It's at this point, it's really just historical reasons. I think it has to do with like the way old monitors would like refresh. They would have like a refresh rate, like old CRT monitors, like the big ones that looked like the old style TVs. That if you threw them out a window, they would, the vacuum tube would shatter and everything. Those old monitors, they would refresh left to right, top to bottom. And so if you were doing graphics, you sort of needed to start drawing in the top left just because that's what the hardware did. So that just became a convention in computing. And it's not true in every system, but it's true in most systems where 0, 0 is in the top left. And as you move down, the y coordinate increases going down and the x coordinate increases going over. So if this is 0, 0, this might be 100, 100, and this might be 100 in the x and 200 in the y, say. Um, that's just a convention. Sometimes this is called screen coordinates because we're dealing with where things are on a monitor or on a screen to differentiate it from like Cartesian coordinates where, this would be the first quadrant and 0, 0 would be down here. And then this would be, is this quadrant 2 or is this quadrant 2? I can't remember. One, whatever. And then this, I don't know, whatever it is, 1, 2, 3, 4, whatever. The other quadrants of Cartesian coordinates. Not important. So we got this. That's basically everything you need to know. The super call establishes the size, and then these add objects stick all these basic objects that we created into our scene. Tells you where. And then how did they figure out these numbers? I don't know. They tried some stuff. They were like, should we put the hedgehog at 600, 100? Let's recompile. Nope, that's off the screen. So let's go back 300, 100. Oh, that looks pretty good. I should also mention that these numbers, this tells you where the center of the image is going to go, or the center of the object, not like its top left corner, which is true in some other systems. So this is where the middle of it's going to go. So if we put it at, for example, 0 in the y direction, you can see it's like half on, half off, because the middle of it is at position, 0 for y, which means that the sort of top of the hedgehog is like off the screen because it's negative in the y direction. Um, so I'll just undo this. And this is one of my favorite things about computing is I don't need to know anything. I mean, I need to know some basics of syntax and stuff like that. But if I want to know what something does, sometimes it's easier to just like try it out and see what happens. So that's our hedgehog. You know, a hedgehog and the 2 balloons and the 4 pieces of pizza. So that's where everything gets established, and that's our world. Let me go back to here for a second and see what we've got next. So let's talk about the actors. Let's talk about balloon, pizza, and phone first. So first of all, phone doesn't do anything. It's an actor that has an act method that doesn't do anything. So this means like Animation is somewhere between 30 to 60 frames a second. That means like 30 to 60 times a second, this method gets called and like updates, but it's not updating anything. It's just there. It doesn't do anything. So phone literally does nothing. If we look at balloon, so what does balloon do? Well, this moves three, and if it's at the edge, it turns 180 degrees and moves three again. Let's look at what that looks like in practice. So if we run it, you can see we have 0 points and 3 lives. The hedgehog's up here. And if we use our arrow keys, we can move the hedgehog around. And you can see those balloons are bouncing around. If I get down here and a balloon hits me, you see I lost a life. I'm down to 2 lives. Now, if I eat a pizza, I get a point, and then I get another point. And then if I get down here, woohoo, I get a point. And then if I get this point, I win. So I have 4 points and I've won. Now, also, if I get up here, I can lose lives, and my lives can actually go negative, you know, and then I can win and lose at the same time because I ran out of lives and I got all the points. There's a lot of conditions that this simple program doesn't include, but basically, you can see the balloons every um, you know, 30 times a second or something like that, that act method gets called, which causes the balloon to move three. And when you say move, it just moves in whatever direction it's facing. When you create a new something and a new actor, it's facing sort of this way, 90 degrees. So if this is 0 degrees, would be straight up. 90 degrees is this way. So it's moving in that direction. Is that edge? What does that do? Well, that just says, am I at the edge? Am I at the edge of the screen? Top, right, bottom, or left. If I'm at the edge, if I am at the edge, we're saying turn 180 degrees. So twist, 180 degrees, and then move three. So I kind of bounce off the wall. So if we watch what's happening, you can see those, and that's why you can see the balloons are sort of temporarily going upside down because they're turning 180 degrees. So that's kind of cool. And then when you're done, you can pause it or you can just reset to sort of reset everything back. This actually reset is actually recalls the my world constructor. So it like throws everything out, calls my world again, and like resets the scene with whatever is in the my world constructor. So that's actually pretty convenient. So that's the balloon. The phone doesn't do anything. It's in there because they were going to have a way to something. I don't know why it's in there. Doesn't do anything. If we look at the pizza also doesn't do anything. It just doesn't do anything. It gets set in the scene, but doesn't do anything. It's there so the hedgehog can intersect it and then eat it. And we'll show you how to do that. So all the logic is actually contained in hedgehog. So we got that. Let's see what we've got here. So hedgehog, state, moving and eating pizza. Yeah. So hedgehog, this is where it's at. So let's really dig into hedgehog here. Where are you, hedgehog? Boom, there you are. So you can see hedgehog. Look at this. This is 100 lines of code. It's not literally because a lot of it's comments and whatever. So you can see these variables here: speed, lives, and points. You can imagine what those are. If we run this, point and lives, and then speed is like how fast the hedgehog moves. Nothing super surprising there. So you start with 0 points, you start with 3 lives, you lose a life every time a balloon touches you, and your speed is 2. That's sort of how fast you're moving when you hit the arrow key. So we look at this act method. We have move with keys, we have show status, hit pizza, and so on and so forth. The order I put this is we'll start with move with keys. Because that's kind of the critical method for navigating the hedgehog. So if you look at this, we have this greenfoot.isKeyDownRight. So that's something built into Greenfoot that you can see this is actually a static method inside the Greenfoot class. Now, where is that Greenfoot class? Well, it's, believe it or not, if we go back to the top of here, we go to the Greenfoot package, it's in the Greenfoot class, and you can see we have a whole bunch of things: get key, delay, get mouse info, get mic level if you're doing microphone input, get a random number, is key down, you can do the key name, is the mouse clicked, mouse dragged, mouse ended, there's a whole bunch of things in here just for like getting and checking different types of inputs. So that's what we're doing here. So we're saying, hey, if is key down, and this string right just means right arrow, and then left means left arrow, and up and down or up and down arrow. Now you notice that this is lowercase, this is uppercase. These are not case sensitive. I can understand any variation of it as long as it's spelled correctly. So the punctuation doesn't matter. What that means is like this method is either taking this and converting it to all uppercase and all lowercase, and then just checking it against the canonical version. So if we hit the right key, what are we doing? Well, we're setting location. what is this method? Well, we are an actor now. Hedgehog extends actor. So what does that mean? That means that we inherit all of the, let's go to actor, which is here. We inherit all of these methods. So we have this set location method, which takes an X and a Y. Um, we also have get location. Do we not have get location? Get, really? How do we, how do we, how do we figure out where we are? Move with keys. Oh, it's just get X and get Y. It's not get location. Duh. We just have a method get X that gets your X coordinate and get Y that gets your Y. Of course, we wouldn't have get location because how would you return two variables? You would have to create a point class. Would you return an array? Who knows? That makes a lot more sense. So set location can take two parameters, X and Y, but then we just have get X and get Y for figuring out where we are. So we get our current X and we add speed. Why? Well, if we sort of look at this, here we are. Remember, X coordinates get bigger as we go right, and Y coordinates get bigger as we go down. So if we move right, we leave the Y coordinate alone, right? So if we look at this, the new Y is just the same, and the X is whatever X was plus speed. So there's that speed variable. Left, we just sort of subtract. So that, goes this way. And then up and down, up, remember, we subtract because wherever we are here, suppose here we're at 300, 200. If we want to go up, the up arrow, well, this is, what is this? 100 in the Y direction. If you want to go up two, you would go to 98 in the Y direction. That would move up slightly. Because remember, this is 0, 0, and 0 in the Y direction. And then this is 400 in the Y direction because we're 600 wide by 400 tall. Yeah, so that's what we're doing is we're just setting location to, whatever our old location was, get X, get Y, plus or minus speed to the X or the Y coordinate. And that is all there is to moving the hedgehog. That's pretty fantastic. So and we've sort of taken this act method, we've factored that out into its own method, which is kind of nice. So once this method finishes, it will have moved the hedgehog if any of these keys are down. If none of these keys are down, the hedgehog won't move. Okay, so then we show status. What does this do? This just gets the world and shows the text lives and points. So it just, and if lives and points have changed, if these variables have changed up here, it's just going to update it. You can see they had a constructor at one point, this no arguments constructor. Then they decided, like, you know what? We don't even really need that because if you don't provide a constructor, Java provides one for you. And if you just initialize these to the values you want, Java will just take these assignments and shove them into the constructor and then build the constructor for you. So whoever wrote this started out with the constructor just like, I don't even need this. And they got rid of it. And then why did I leave this comment in there rather than deleting it? I don't know, just to mention default constructors because it's a nice thing to know. Okay, so show status just shows whatever the status is. So this is like the string you want to show, and this is the location, 50 in the X direction, 30 in the Y direction. So if you look at this and we run this, 50 in the X direction and 30 in the Y direction, 50, and then what is it? 50, 30, and 50, 10. And which is which? Yeah, lives is 50, 30, and points is 50, 10. So this is very little in the Y direction. And then this is a little bit more in the Y direction. And I'm pretty sure these, again, are not top left justified. I'm pretty sure that's the middle, right? So if this is 10-point font, that should be touching up against the top. Doesn't really matter. It looks fine. They probably just tried out some different things and got that to look pretty good. Add points and lose life. These methods just sort of do what it looks like they do. So nothing exciting there. Let's look at hit pizza. So hit pizza, when does this get called? This gets called here. So after we show the status, we do hit pizza. What does hit pizza do? Well, if is touching pizza. Now, what is this touching? This is another one of these methods that we inherit from good old actor, the actor class. And so is touching, we check it against another class. What does that mean? Well, we're actually doing pizza.class. This is a thing you can do in Java using, it's basically reflection, which means you're having the code like stare inward at itself and thinking of itself as code. They call that reflection. So we're saying like, don't check if you're touching a variable or an integer or a string or something like that. Check if you're touching anything that is of the class pizza. And since pizza here is one of our classes, because we created it, this will check, hey, am I touching anything that's a pizza? And if I am, remove Remove touching says, hey, remove everything of this class that I'm touching. And if I'm not touching anything in this class, this shouldn't do anything. And then if we do that, go ahead and add points. So that basically allows us to sort of gain points for touching a pizza. And then every time we touch a pizza, we remove it. So this is really nice the way this is built. We can check if we're touching any pizza, because remember, there's four pizzas and we don't care which one we're touching. We just care that we're touching one. And then remove touching. This doesn't remove all the pizzas because there's four of them. It just removes whichever one or whichever ones, if they're very close together, that the hedgehog is touching, and then goes ahead and adds points. So these methods look really simple, but they're actually really flexible and really powerful. Hit balloon is similar. If we're touching a balloon, set location 300, 100, this warps the hedgehog back to its starting point, which is here. So if you're down here, you're moving around, you get hit by a balloon, you get warped back here, except you lose a life. And again, add points and lose life. Excuse me. These just adjust instance variables. Nothing too surprising there. Test endgame if lives is less than one. We sort of put out the you lose text at this location, and if win game if points is greater than three, we put this out. And there's nothing to prevent. There's no ands in here. Like if lives is less than one and you haven't already won or something like that. There's no extra conditions in here, so you can both win and lose the game at the same time. And that's really it. I mean, that's kind of all we have. Oh, whoa! I'm trying to. Oh, that's a fun other thing you can do is I can't remember exactly how I did that. What did I do? Oh, I hit new hedgehog, right? So that calls the constructor, and I can stick another hedgehog in. Now this doesn't adjust this constructor, right? These are just like extra hedgehogs I created. If I hit reset, they go away. So I've done new hedgehog and like dropped it here. And so now if I run this, these hedgehogs will move in unison, at least unless they get hit, because the hedgehogs are both responding to the arrow keys. So that's kind of a weird thing that you can do is like while you have a scene here, you can like, you know, hey, let me make a new phone and stick a phone here for no apparent reason. But then anytime you reset, it just goes back to only the things that are in the constructor. So that is what we've got in here for. So then this was move with keys. This was hit pizza and hit balloon. This was show status. That's basically everything. So this, again, pretty simple, but really demonstrates in not that much code a lot of the power, sophistication, and flexibility and opportunities that Greenfoot provides. I'm going to stop this part of the video and then I'll record the next one separately and then splice them together in case I make a million mistakes on the second one. So thanks for watching.